Alright, so this is the problem description part of this workshop. So as I told you in the introduction part that we are going to solve the problem of the tank emptying. So what will happen is that the initial tank will be filled with the whole tank will be filled with the water, and as we will be draining the tank from bottom through orifice, the part where the liquid will be not be there, the water will not be there, will be filled with the air. And so you can see this is a free surface type of the flow simulation here, and this air will be coming from the top side, and top side we will define as the pressure outlet, and so is the orifice. And the remaining two boundaries, which are the bottom wall and the side wall of one circular wall, will be defined as a no slip condition, no slip wall. And although we have the idea about how much time it will take to empty tank, but we also get this data or this time from the simulation, from series simulation using the VF model. So in this workshop you will learn how to set up the transient two-phase problem using the VF or the volume of fluid method in Fluent, and how to set up the primary and secondary phase in the VF model. So the fact is that you will be using the primary phase as the air and secondary phase as the water. So there can be two explanations. One is that we will choose the lighter fluid as a primary phase, and the heavier fluid means that with the higher density as secondary fluid. This is one thing. Second logic is that you will choose a fluid which will be will be there in the domain. So for example, in this case the water will be there initially, and once it's drained out, the primary phase, the major phase will be the air. Means that when the whole water will be gone through the bottom of the tank through the orifice, the dominant phase in this control volume would be the would be the air. So that's why that phase will be selected as the primary phase. And then we will select the operating conditions. In the operating conditions, the default pressure is a 101.325 pascals. We will just keep it. And however, we will be setting the working density or the density of the main fluid or the main phase. And as discussed here, that will be air. That's why I will be putting the value of 1.225. And this is very important, and this will help the problem to solve very smoothly. And then we will be learning about how to calculate time step, number one thing. And number two thing is that how to use the adaptive time stepping. So you can use a fixed one, and you can also use the adaptive. Adaptive means that the solver will select the time step based on the current number, and current number usually speaking we select the 2 or maybe 1. And based on that value, time step will be limited by local conditions. So this is a better approach as compared to fixed one, because in the fixed one we don't know exactly what are the velocity scales in the domain right now, and at how much time the velocity is there. So maybe we don't know that the time it will take to move from one cell to second cell is how much. Maybe we give the very low time step, maybe we give the higher time step, in both cases which are not good for the simulation. And also we have one of the purpose of this workshop is to how to post process results in the CFD post, and for that we have to export the files from Fluid automatically. So what I want is that I want that the only results should be written in a separate file with all the time history. So instead of loading all the Fluid files at each and every time step, all the case and data file for each and every time step, what I want here is that the Fluid should be only writing the data of my variables and my parameters and their variation with the time, so that I can post process them. I can make the animations in the CFD post, and CFD post is better on this aspect as compared to the default post processing capabilities inside the Fluent. So this is already covered here, and then finally we will be comparing analytical and CR results. So analytical and CR results, they are will be in terms of the how much time it has taken to empty the tank.